All right, today what we're going to be talking about are trig ratios, finding the side and the angles. So one of the things that we can use, it's a little mnemonic or something to help you remember, is SOHCAHTOA. So we can use that to help missing sides and angles in a right triangle. So there's some important terms that you need to understand. First off, when you have this symbol, it's called theta. What we use theta for is whatever the angle is. So that's the Greek letter theta. And in a right triangle, there's some special parts to it. So we all know the hypotenuse is the hypotenuse, but then we have two legs. Those legs have specific names depending on where the angle is. So what we're going to talk about here are some ratios, which is sine, and you say that sine, oops. So sine, not sin, is a ratio of the opposite over the hypotenuse. So cosine is that, the abbreviation. So the cosine of theta is the adjacent over the hypotenuse. So that's the ratio for cosine. And then tangent of theta is your opposite over adjacent. So there's a couple little tricks as SOHCAHTOA, or you can remember it like this, which ratio goes with what. Now, what's important is to determine which one is the adjacent and which one's the hypotenuse. So you always want to look for your angle. Now, hypotenuse is always going to be hypotenuse. It's always across from the right angle. So hypotenuse is easy. The opposite and adjacent are the ones you have to watch out for. So look for your angle. The opposite is always going to be across from theta. The adjacent shares the side with theta. So your hypotenuse and adjacent should have the angle between them. So adjacent. So now let's go ahead and let's look here. And we're going to determine opposites, adjacent, and hypotenuse. So I always look for my right angle because I know my hypotenuse is always going to be the hypotenuse. Now, we're looking for our angle. Across from the angle is your opposite. And if it shares the side with the hypotenuse, that's your adjacent. So here's my right angle. So hypotenuse, that should be the easy one. Here's theta, here's your angle. So across from your angle is your opposite, and if it shares the side with it, it's the adjacent. All right, so I want you to look here. So here's my right angle. So across from it, that's your hypotenuse. Now your angle is here. So across from here, this is going to be opposite, and since this side shares it, this is going to be your adjacent. All right, I want you to try those. I did highlight the angles for you, so you know what you're looking for. All right, so now what we're going to do is we're going to express each as a fraction in simplest form. So we have our right triangle here, but first you need to figure out what this side is. So we're going to do that by doing a squared plus b squared equals c squared. And I just plugged in the information that we have here. We don't know this yet. That's what we're looking for. And so I'm going to get a equals 27. Now we know what that side is. So we're going to use SOHCAHTOA, or if you like it written this way, you could do that too. I just write it this way. All right, so sine is opposite over hypotenuse. So we're looking for G here. So opposite is 36. Hypotenuse is always going to be hypotenuse, which is 45. And then I just simplified that to 4/5. Now cosine of G, cosine is adjacent over hypotenuse. So since we're looking here, this is adjacent because it shares the side, and hypotenuse is always the hypotenuse, which simplifies to 3/5. All right, so now let's look at tangent of E. Tangent is opposite over adjacent, but we're looking over here. Opposite in this case is 27. And then adjacent shares the side, which is 36. So I want you to go ahead, I want you to try those to do the ratios. All right, so now we're going to use trig functions with a calculator. This you need a calculator for. All right, so the most important thing is when we're doing trig, your calculator must be in degree mode. So I'll show you how to do this. You're going to click mode. We'll go here. So you're going to click mode, and then you're going to make sure it says degree. So that's radian, that's degree right there, okay? Once you got that, then you're good, and you can go back. So you're going to switch from radian to degree and then click enter. All right, so we're going to evaluate the following using your calculator, round to the nearest hundred. So you're going to go sine 62. So we're going to go back to here, and we've got this. We pressed enter, so we should be good. All right, so we're going to go sine, and then what was it, 62, I believe? Yes, 62. And then press enter, and then that's your answer. And so we said that was point, and we'll just round it to the nearest thousandth. All right, so when you're doing this, if you look at you've got your sine, cosine, tangent. So those are all the buttons you're going to press. And so you would just go sine 62, then press enter. So pretty easy. All right, then the next one is cosine 132. Then press enter, and then that's going to give you your answer there. So go ahead, and I want you to try these round to the nearest thousandths. There's the calculator. All right, so now what we're going to do is we're going to solve, and we're going to round to the nearest tenth. So in this case, we have sine of 23 equals x over 15. So we're going to set this up as a proportion, and we're going to cross multiply. When we get that, we get 1x equals, and I usually like to write it this way first, sine 23. So 15 times sine 23, enter that into your calculator. So go 15 times sine, 15 times sine 23 equals, and you get that, 5.86. And we rounded that to 5.9. All right, so this one, I want you to go ahead and try that one. Again, remember, set up as proportion and then cross multiply. All right, now this one's a little different because when you set up as a proportion and you cross multiply, you're going to get y times the tangent 60 equals 3. Well, if you notice, y is on this same side. So we have to get y by itself by dividing both sides by tangent 60. This is going to cancel out, and then you're left with y equals 3 over tangent 60. Okay, now we're going to come over here, just enter that in, but just make sure you go 3 divided, clear, 3 divided by tangent 60, press enter, and there's your answer. You get 1.73, so we're rounding to the nearest tenth, which is, 1.7, all right? Now, finding the side. So now if we're going to find the side, it's pretty easy. You just got to know which one's what. So use that to determine. So again, use SOHCAHTOA. And if it gives you sine, we know we're going to use sine because it's giving us our opposite and it's giving us our hypotenuse. So this is what you do here. Just plug in information you know. And then we're going to say opposite over hypotenuse. Set up your proportion, cross multiply, and you'll get b equals 9.2. So pretty easy. So here, it gives us this, which is your adjacent and your hypotenuse. Well, cosine uses adjacent and hypotenuse. So that's what we're going to do. Plug this in. And then we said adjacent over hypotenuse. Set that up, cross multiply, and you'll get 25 times cosine of 54. Enter that into the calculator, you get 14.7. Go ahead, try that one. Now this one again, remember it's a little tricky because from here you have your opposite, and then from here you have your adjacent. So opposite and adjacent is tangent. So that's what I wrote here. Tangent of theta is opposite over adjacent. So we're going to say tangent of 20 equals opposite over adjacent. Cross multiply, and you're going to get x times tangent 20 equals 10. And remember, you have to divide both sides by tangent 20. That cancels out, and you're left with x equals 10 over this. When you put it into the calculator, you get that. All right, I want you guys to try those. And then now we need to find the missing angle. So if we need to find the sides, so trig ratio, oops, sorry. This is for sides. Where'd it go? So missing sides. And then we're going to use this one for missing angles. All right, so we're going to do what's called the inverse. So we're going to do this one, we're kind of going opposite of it. So we're actually going to say inverse sine times opposite over hypotenuse equals theta. So we're looking for the angles. So remember, just the regular is for sides, the inverse is for your angles. So we can do that to all of these, where you're still going to have the same ratio, but this time you're just looking for the angle. All right, so to do that, you have to click the second button, then sine, cosine, tangent. So if you look here, I'll do this in a bright color. All right, so you're going to click the second button, and then you're going to do sine, cosine, tangent. And if you look, you'll see on top, if I zoom in, you'll see on top, that's the inverse sine, so it's right above it. So you got to press second, then sine. And so to do inverse, you got to press second button. And then that's going to be your sine, cosine, tangent. Okay, for sides, you're just going to do regular sine, cosine, tangent. All right, so now let's go ahead. I'm going to show you on the calculator how to do this. So we're going to enter all of this in. So I have, oops, clear all of that. So I'm going to go second sine, and if you notice, it brings that up, and you're going to go 12 divided by 17, and then press enter. And that's what you should get is 44.9, which goes to 45. All right. And then same thing here, and then same thing here. So check these. If you did this correctly, you should have gotten 57 and 41. So let's go check it real quick. I'm going to have second cosine, and then you're going to go 7 divided by 13. All right, looks good. And then the last one was inverse tangent, and then you're going 13 divided by 15. Press enter, and there you go. So you should have those answers for those, and I want you to go ahead, I want you to try those. All right, so to find your angle, select the angle. And I know this is adjacent and this is opposite. Or if I were to use this angle, this is adjacent and this is opposite. So it just depends on which proportion you want to use. So let's look here for this first one. So I know since this is across, it's opposite. Hypotenuse is always going to be the hypotenuse. So I've got opposite. Oops, wrong color. Sine is opposite over hypotenuse, but since we're looking for the angle, now we have to do the inverse All right, so you're going to go through, you're going to do the calculator where you're going to go inverse sine, plug that in, and you should get 27 degrees. All right, same thing here. So looking here, if I'm looking at this angle, that I know this shares the side with the angle, so it's adjacent, and hypotenuse is always hypotenuse, which is 34. So I know cosine is this, whoops. So since we're looking for the angle, we have to do the inverse. All right, so you're going to go through, enter this in on your calculator because it is adjacent over hypotenuse, adjacent over hypotenuse, and you should get 56. All right, so what I want you to do is I want you to go through and I want you to find those using these as examples. And then that is your trig ratios.